standard form of quadratic function. Higher order thinking. The quadratic function whose graph is shown represents a serial bubble. Its equation is y is equal to 0.32x squared minus 1.6x plus 2. Describe how you could use the function to find the diameter of the serial bubble if you know its depth. So this is the graph of the function that describes this function here. But now let's try and graph this function in a graphing utilities. But I'm using here Desmos. This is the function, and this is graph of the function. Now here, if we are looking, for example, axis of symmetry, here is the vertex, and the axis of symmetry is 2.5. So it's here in the middle axis of symmetry that divides the graph of the function into symmetrical sides. And now we want to know if we know the depth, can we find the diameter? Yes, if we know the depth. For example, the depth is a 10 here, for example, or here is a 5, and I know the diameter is one point is here and the other point here, and we can know this a diameter. We know 2 points here, and from this point to this point is the diameter. And the same thing, you can take any point, but let me take, for example, y is a 10. So let's say here is a 10, and from axis of symmetry to this point here is 8.09, and this point here. So diameter is from this point to this point here. Those 2 points determine the diameter of the bubble. If we can take any point, for example, if we take a y is equal to 5, so now here is the diameter from this point to this point here. But we can take any point of the y, of the depth, and we can find out what is the diameter of the bubble. But just for the illustration of the problem, let's take those information, and let me take for instance, I need just this point 8.09. I need the vertex to know, and I can find out what is the diameter. So let me demonstrate here in the example here. We already know the vertex here. This vertex, this point here, is a 2.5 and 0. So 2.5 and 0. We already know this point. So, and the other point, what I was interested to know, when y is equal to 10. So, and I want to know this from this point here. Let me write with a different color. So this I want to know this distance from the y coordinate to this point here is was 8.09, 09 and 09, and it was y is 10, the depth. If we know the depth, then we can find out the diameter. And now axis of symmetry. Let me draw this axis of symmetry with a different color. This is axis of symmetry. It is in 0, but from the coordinate point, so I am denoting just the distance x, this distance, horizontal distance. It is a 2.5, this distance. But hold this distance here from this point to this point here, from the coordinate point to the 8.09 is 8.09 is 8.09. So let me write this distance here, because I want this to write. This is 8.09. 8.09. But this distance here, now if we want to write this distance here, this is a half of diameter. From here to this point here is a half of diameter. So it's d over 2. And I want to find this d over 2, what is equal. The d over 2 is this distance here minus the coordinate from the ordinate from the 0 to the axis of symmetry, from the y coordinate to the axis of symmetry. It means d over 2 is equal with 8.09 minus 2.5. Let me write d over 2. This is not the whole diameter, it's half of the diameter, 2.5. When you put this in a calculator, you are going to get the result 5.59. 5.59 units. We don't know whatever units we are looking for. If we are looking, for example, centimeter or inches or whatever, and we don't know what kind of units because the units are not given. Let's say units. I write units. But because the diameter is 2 times the half of diameter, so just the diameter is, we just multiply this number by 2, and we get then we get the diameter is 2 times 2, 5.59. 5.59 units, and we get the diameter of the bubble. Then the depth is 10 units. Then the diameter of the bubble is going to be, when you multiply, you get 11.18. So this takes care of calculator. It's not a big deal, but I am more interested in the concept of this problem. And that's how we get to the diameter of the bubble when we know the depth of the serial bubble.